you have something that is literally going to end humanity if we don't address it, and yet it is also such a boon to humanity with what we can do with it.
Yeah. Unless you start doing hand-wavy warp drives and stuff like that. Our understanding right now is you have to kick something out the back.
Just a couple degrees. Why does that matter so much?
And so if you want this much gravity in your spacecraft, you have to take Earth with you.
Rocky has my heart.
I'm sorry, Rocky's an engineer. I have a thing for engineers.
Yeah. Welcome everyone to Aerospace Cookies. We are here because I really like Project Hail Mary, and I made everyone in my friend group and family read it, and then they made a movie. So now you get to listen to it. So we're just going to talk about what I loved in the book that couldn't make it into the movie for very obvious reasons. And that is the really hard, deep, complicated science. So that's why we have him here, because he gets it more than me.
Looking forward to it.
Great. So do you want to explain why you would know so much about aerospace really quick? Give us your qualifications.
I just read a little bit. No. So what Iliana is referring to is my career. I've been working for about 30 years in the aerospace industry. Had an opportunity to work at Hughes, which is now Boeing. Worked at TRW, which is now Northrop Grumman. Worked at NASA Jet Propulsion Laboratory for a while on the Mars programs. There, the Mars exploration rovers, Spirit and Opportunity. I was one of a cast of thousands that worked on those rovers. They were fantastic. And a bunch of other programs for the last 30 years. My particular specialty is the avionics systems, those little black boxes inside the satellites and spacecraft that need to talk to each other. I'm the guy who gets those working.
It's also just your special interest, space.
Yes, I love space. It's why my career went the way it did, is because of how much I love space exploration.
Yeah, which is why, so a friend introduced me to Project Hail Mary, listened to the audiobook, loved the audiobook. Either version's good, to be clear, but if you get the chance to listen to the audiobook too, the narrator is fantastic. But I got you to read it, and I believe the first thing you said to me after reading the book was, I want some astrophage.
Well, so the it's science fiction, of course.
Yeah.
And the wonderful thing about real science fiction, we're not talking the future fantasy like, Star Wars, but more the actual science fiction, is what if. And that's what science fiction is. It's what if. And so Andy Weir in his book was, what if something started eating the sun, yet we could use it for propulsion? Should we tell people that this is going to be a lot of spoilers?
Yeah, probably. From here on out, you can expect a lot of spoilers.
The whole thing. And so, so that was the big what if in Andy Weir's Project Hail Mary, is what if something started eating the sun, and then we could obtain, quantum level energy from this thing.
Honestly, that was one of the things I loved about the book, is that you have something that is literally going to end humanity if we don't address it, and yet it is also such a boon to humanity with what we can do with it.
Yeah, it's kind of the dichotomy of that, is you have something that can destroy mankind, but it also then elevates them to the stars.
Exactly. So can you talk to me a little bit, and our audience more importantly, about why astrophage is so cool? Because I feel like in the movie, they get to talk about how they're using it for fuel. But in the book, we also talk about how it protects against radiation, how it has, what is it called? It's able to store power, neutrinos, I believe. So talk to me about why we can use it in these ways, or I say we like we lived there, but
right. Well, I obviously I haven't had a chance to talk to Andy Weir about his thinking in developing this story, but in any space travel story, the absolute biggest problem is getting enough energy to propel a vehicle. Newton's laws, everybody's heard the action reaction. You fire a rifle, there's the recoil from the rifle as the bullet moves forward. Something has to go backwards when something goes forwards. And it's the same with space travel and rocketry, unless you start doing hand-wavy warp drives and stuff like that. Our understanding right now is you have to kick something out the back. And we go to Einstein's equation of relativity, the E equals mc squared, and that's where astrophage comes in. Astrophage is the m that can be converted times c squared to energy. So I guess I should explain that a
Yeah,
little bit.
explain it like I'm 5.
Right, exactly. So they used to believe that matter could never be created or destroyed. Matter was eternal. We now understand that's not true. Matter can be annihilated and converted to energy. And we're talking, there's no particles left. It's just pure energy. And so when you annihilate mass, the amount of mass that you annihilate, the energy you get out of that is equal to the speed of light squared. So it's the mass in kilograms times the speed of light in meters per second times the speed of light in meters per second. And speed of light, of course, is extremely fast. We're talking incredibly large numbers. You know, in the book, and they included in the movie, there was a mix-up in the amount of astrophage they gave to a couple of researchers, the primary scientist that was going on the mission and the backup scientist who was going on the mission. And they gave them 1,000 times more. They gave them, I can't remember, a nanogram instead of a picogram or something like that.
Which
and that
is
was
still an insanely small amount in the scheme of things.
right. No, I mean, you need a microscope to see it, and yet it completely wiped out that building. So the amount of energy in that mass, and of course that's the what if with the astrophage is, what if there is something where we can store and release energy at that level that Einstein, of course, had calculated.
Which means it's just super cool.
Yeah, exactly. It's really cool. Uh-huh.
I also love it as a solution to space travel. You know, the common question is when writing science fiction, these are vast distances to get communication and to get people. And so I loved
Yes.
his solution of something I had never seen before
Mm-hmm.
in having astrophage be the magic solution as opposed to a warp drive or solar sails or whatever
Yes.
else.
Mm-hmm.
So, talking about the bad side of astrophage now,
Yes.
it's eating our sun.
Right. It's eating the sun.
Can't be good.
And they did not really get into that in the movie, how incredibly bad that was.
No, but I actually did. I have, since seeing the movie and having that initial conversation with you after the movie, have several
Mm-hmm.
conversations with people who haven't read the book, only watched the movie.
Mm-hmm.
And they did say, no, I definitely got that the sun was dying and there were
good.
stakes.
Good,
so
good.
I feel like maybe I just have more from the book. But the truth is, the book, I don't remember the exact numbers, but they had calculated the sun was only going to get only a few degrees colder.
Yes.
And that was going to end humanity.
Yes.
So why just a couple degrees? Why does that matter so much?
So when you're looking at, you know, our planet can't survive without energy from the sun. Is period, full stop. You know, if we don't have energy from the sun, we look like Pluto. And if you've seen a picture of Pluto, it is a giant ice ball because everything's frozen. You go.
It has a heart, though.
It has a beautiful heart. You know, I think someone was sending humanity a message. I love you. How do you do it? Oh yeah.
Yes. I am personally offended by Pluto losing its planetary status, even if it makes perfect sense.
Okay. I'm not so sure about that because it's still a dwarf planet. And the way I look at it, we didn't lose Pluto. We gained Ceres, which is a large asteroid, now a planet between Mars and Jupiter, as well as what they call the TNOs, the trans-Neptunian objects. So Makemake, Haumea, Eris. We gained a lot of planets.
Okay.
But nobody's memorizing them.
That's fair.
Yeah, Pluto got ripped off. Totally got ripped off.
It's just the odd man out.
Yeah.
But back to your initial point about
yes.
Earth turning into an ice ball.
We go from Pluto back in, we get to Saturn and its largest moon, Titan. It is so cold that methane, which is a gas here on Earth, is liquid oceans on Titan. It is that cold. So when you look at Earth as an object, it's getting all this solar energy, obviously from the sun, And there's something called albedo. It's a property of planets, and it's how much is bounced off. And so I can't remember Earth's albedo, but you've got the solar energy hitting the Earth, you've got light coming off, and then you also have, you've got the magnetic field around the Earth. This repels some of the energy from the sun that's harmful to life. Without the magnetic field, life probably never would have started because it would have gotten, microwaved basically. Which is, just to throw in an aside, that's a big concern with sending people to the moon because they leave Earth's protective magnetic field and sending people to Mars. Mars has a magnetic field, but it is almost non-existent. So you've got that, you've got the ozone layer, you've got all these different layers that protect the Earth from the energy. So if you drop the percentage of the temperature of the sun, you're not only losing that percentage, but you're also losing more than that because of all these protective layers that reduce the total energy incident on the Earth. But another thing that people don't consider, do you ever wonder why chlorophyll is green?
I have never considered that, actually.
No. So if you look at the sun, it obviously emits energy, and it emits energy all the way down in the radio waves. We're talking electromagnetic spectrum, radio waves, through to visible light, beyond that to X-rays, to gamma rays. And it makes this giant hump, a sine curve, basically, or they call it a bell curve. What the peak of that bell curve is the peak temperature of the sun. And at that temperature, the maximum amount of energy that comes out of the sun is green light.
Oh.
So what we see is the whole curve, but the peak is green light, which is the center of our vision, and it's the color of chlorophyll. It gives chlorophyll the maximum absorption at that peak. So that peak is related to the temperature. You reduce the temperature, you shift the peak. Chlorophyll becomes less efficient at absorbing the energy from the sun just by changing its temperature. Even if you reduce the amount of energy, if you leave the amount of energy the same, you change the temperature and it shifts that peak energy and the chlorophyll loses efficiency. I'm pointing over here because that's the backyard. It's where the grass is.
So I just want to make sure I understand what you're saying. Basically, plants would be unable to produce as much oxygen if it got colder. Not just because they're freezing, but because of
everything. The photosynthesis takes carbon dioxide and water and converts it primarily to oxygen and carbon chains, sugars, potatoes, leaves, flowers, all those kinds of things. So yeah, it becomes less efficient. So it's not able to grow as well.
Not to mention, you start getting ice age effects.
Yes. So temperatures drop, and we have plants in certain temperate regions for a reason. Ask any gardener. Yeah. You're not going to be able to plant a date tree, a palm date tree in Utah. It's just not a climate where it can survive. So climates are going to completely shift, and the plants aren't going anywhere. So the plants are going to find themselves in a climate where they can't survive. So,
which the beauty of Project Hail Mary that unfortunately doesn't make it into the books is all the efforts they are doing, not just on Project Hail Mary, but Project Save Humanity, who's stuck here during this mission.
Yes.
I don't know what project you want to call that, but talking about how do we make world governments work together? How do we share food? How do we distribute food? How do we get people closer to the center of the earth?
They make that point in the movie, the character who's running Project Hail Mary, she says, we're going to lose this much of humanity, this much production, assuming the governments work together.
Which is a big assumption.
It's a false assumption.
Yeah. But even just, here's a plug for another book series,
okay.
Bobverse. You've
been telling me about that.
I know. I'm going to get you to read it. But
it.
similar climate catastrophe without spoilers, and there is a discussion of basically what would happen on Earth if there was a similar. I don't want to spoil the book for anyone since we aren't talking about Bobverse today, But similar catastrophe, how does humanity survive and what portion does?
So if we're plugging things, I would plug the video game Horizon Zero Dawn, which is another end of Earth scenario, but that has already happened, and you learn about it from the perspective of the game, what the prior history was.
You can't tell we like nerdy things.
Yes, we do.
But I was listening to an interview with, I'm afraid I should have looked this up ahead of time. I'll put it in the comments below or something if I can find it. But it was either the director or the producer, and they had like 10 things they absolutely wanted to get into the movie no matter what, and they got 9 of them.
Okay.
And
what was the one they couldn't get?
blowing up the Arctic.
Yeah, that would have been some great special effects.
So, for those of you who haven't read it, who haven't seen, or I mean, haven't read the book but have seen the movie, one of the things they do is they go to a climatologist, or I don't know if that's the official term for them, actually.
I think so.
Either way, they go to
Climate
this
scientist.
guy, yeah, who said, and they're like, hey, you've been studying global warming all of these years.
Instead of stopping it, we need you to ramp it up.
And they basically say, what would be the absolute worst thing we could do to accelerate global warming? And he's like, well, if we blow up an ice cap, then it would release all this methane gas, blah, blah, blah. And they're like, excellent, we're doing that. And this poor guy is just, it kind of destroys his...
Yeah, his purpose of life.
Yeah, because he spent all this year trying to save Earth in a very, very different way.
But of course, Grace, the lead character, his life purpose had been to prove that you don't need water to have life. And when the astrophage was discovered, they're like, oh, this guy's the only person in the world that believes you can have water without life. And clearly that's the astrophage, because it lives on the surface of the sun where you can't have liquid water. And so he's like, okay, I'm a big hero. And they finally get into the inside of the astrophage, and there's water in it. So his life's purpose was also destroyed. So maybe that's a theme of the movie.
Honestly, and the theme is the spirit of humanity, and also Rocky.
Yes.
Rocky isn't human, and yet he has the same human spirit that we talk about, of this drive to go out, to do good, to save, to go on a suicide mission with the slimmest hope, because that's what you can do.
Right.
So let's talk about Rocky, because
Okay.
the star of the show, both the movie and the book. I love Grace, but Rocky has my heart.
Yeah. Well, and I'm sorry, Rocky's an engineer, and I have a thing for engineers.
Yeah, which, again, guys, I loved the movie, don't get me wrong, but that was another thing from the book that we don't get nearly as much of, is his engineering genius.
Yes.
It's their teamwork is undeniable both in the book and the movie, but you get less of how each shined individually in their field.
Because Grace was a biologist, and of course Rocky didn't have those skills, and then Rocky, of course, was an engineer, and they had to work together. We're looking at cross species working together to accomplish something to save 2 worlds.
Yeah.
So it's a beautiful story.
And like every movie, they have to make us a little more comfortable with science we don't understand.
Yeah.
And so scientists become scientists, as opposed to, this is my specialty, this is my specialty, this is my specialty. I think my grandfather, who has a PhD in reproductive biology, always likes to tell me, the more and more I learned more and more about less and less, until I knew absolutely everything about nothing at all.
Which, if you understand calculus, that is just really funny.
Exactly. And so each Grace and Rocky both have their specialties that just aren't as explored in depth with the runtime of the film.
Yes.
But one of the things that really impressed me about Rocky is his experience with relativity. So something that doesn't really get addressed much, if at all, in the movie is relativity, because quite frankly, it hurts everyone's brain. And why it's not part of this story. But in the book, it discusses poor Rocky, who has lost basically his whole crew on the journey here, and he's dealing with relativity. Yes. And he has to just trial and error his way back, or to where he's going. So do you want to talk a little bit about that?
Sure. One of the things I loved about the movie that they couldn't do in the book, of course, was show you how Rocky saw the world. And of course, he saw it through vibrations. So he saw the world more like a porpoise or a whale would see the world with sonar. He saw the vibrations, like Toph
Yes.
in Avatar: The Last Airbender, right? And so his species developed on a world where the atmosphere was much, much, much thicker, and they had no access to visible light as a way of seeing the universe. So, something that was addressed in neither one is how did they ever discover there was space above them and actually get into it? Because they had no sense it was there. We saw the stars and we said, "Oh, I'm going to get some of that," you know. So we developed rockets. Setting aside the military purpose, of course,
Yeah.
which was probably the bigger driver to be fair. So they had no understanding of things that are fundamental to us. Uh, One of the reasons we understand relativity is I can't remember the name of it, but there's a star way, way, way out there, and in front of it there is an invisible object like a black hole that is very, very high mass. And that one object, what they saw, astronomers saw, they saw these four stars. They're like, okay, this is really weird because all of these four stars have the exact same spectral signature. Like, why is that? Well, it was all the same star. Beams of light were being curved by that high mass object between us and that star, and so you got a lens effect from that high mass object that then we saw four of them. So we were able to discover relativity. The Indirians, Rocky's people, never discovered it. So when they took off to go to was Tau Ceti? Tau
Yes.
Ceti, yeah. When they took off to go there, they did not know about relativity. So they loaded up enough fuel for, I think their trip was something like 10 light years. But then, of course, he gets there in 4 or something like that. And he had no idea how he had gotten there so quickly. And the reason he did get there much faster than he thought, and of course, the reason that Grace was able to get there in just 3 or 4 years, even though it was 12 light years away, is because of something called time compression. Of course, for almost all of human existence, we assumed that the clock always ticks at the same speed, assuming you have an infinite battery in it, right? Always at the same speed. But once you begin to speed up and go faster and faster and faster and get closer to the speed of light, the clock starts ticking more slowly. And so you move through time at a slower speed than everybody looking at you. No, sorry, I got that backwards. You start moving at time faster. So his journey for him was only 4 years because of this time compression, where from an outside observer, they saw him take 12 years. And this really breaks the mind, of course. So when Rocky gets to Tau Ceti much faster than he thought he would, he has all this surplus fuel, which is a key plot point, of course. And of course, the other thing they did not understand, because again, they were in an extremely heavy, thick atmosphere, the sun's radiation did not get to the surface of their planet. So they never developed an understanding of some of these much smaller, higher energetic particles that are much like a pool cue that can play with your DNA, like pool balls. And of course, that leads to cancer, radiation sickness, things like that. During some of the early experiments of nuclear energy here in America, there were people who died who were exposed to radiation. One of them, I wish I could remember his name to honor him, but something bad was going to happen. 2 objects got close enough, it was going to go critical and blow up, and he reached in and moved them. So that wouldn't happen, knowing when he did that he would receive a lethal dose of radiation. And that's not a pleasant way to die, and that's what happened to Rocky's crew. Especially the smooth muscle, the intestines, stuff like that are especially susceptible to radiation damage. When you wouldn't remember Chernobyl, but when there's a radiation accident, they will give the population a lot of iodine supplements, and that is because the iodine collects in the thyroid. And I don't remember all the paths of the radioactive decay, but you wind up with a lot of radioactive iodine in the environment. So what they're doing is giving you a lot of iodine to flush any radioactive iodine you might pick up out of your system to help you with radiation sickness. But yeah, radiation at a cellular level is extremely destructive. And that's what happened to Rocky's crew of, what was it, 20 or 30 Endurians, and he was the sole survivor.
Yeah, for like 40 years.
Yes.
This poor
Yeah.
guy.
Yeah. And when Grace realized that, he's like, wow, this guy's made a much bigger sacrifice than I have,
Yeah,
being
to be
alone that
alone.
long. And it's even more poignant because Endurians, when they sleep, they go into a coma. You cannot wake them up. And so they had a culture where when you slept, someone would watch you and protect you. And he was alone and had to sleep alone, which was horrifying to their culture.
Yeah, but he did it, which
Yes.
another,
And
again,
he didn't go crazy.
he didn't go crazy and he kept trying. That was another thing that doesn't get covered as much in the movie as the book, is that his ship has been damaged after all of these years. And that's why they end up using Grace's ship, the Hail Mary, to collect samples and stuff. And that's why Rocky moves in with him specifically. Also with the environmental factors and the fact that Rocky can get in his little ball. But
Yeah, the little hamster ball. That was so awesome. I used to have hamsters as a kid, so that really warmed my heart to see him tumbling around in that little ball.
Oh man, I loved it. It honestly exactly how I pictured it when I read it in the book. It just the chaos of like, I have a roommate now. He's in a ball.
And he had different social boundaries than Grace had.
To put it
Yes,
lightly.
I can hear you.
Who are you talking to?
You can hear me now. Yes, I can hear you now.
Oh man. But Grace and his crew, we coming from Earth knowing about radiation, I mean, we're using it. I mean, not only are we aware of it, we use it in medical treatments for cancer. Like, we
Yes.
have a very fine understanding.
Yeah, the faster
On some level.
a cell grows, the more susceptible it is to cancer, which is why, more susceptible to radiation, and cancer is growing very quickly, which is why it's susceptible to radiation and why they use it. Same thing with chemotherapy. It's growing fast, it's more susceptible to the poison. Chemotherapy, and oh my gosh, my heart goes out to people who have had to go through chemotherapy. You're poisoning the entire body, and it's just the fast-growing cells like the cancer that die the fastest.
Yeah. But going back to Project Hail Mary,
Mm-hmm.
is they, knowing this, they actually used astrophage as a shield from radiation because, again, survives on the sun, doesn't mind radiation much,
Right.
if
Yes.
at all. And so they put it in an entire, like, they had a tiny little two levels, I guess, shielding, and they filled that middle layer with astrophage to
Yes.
protect from radiation, which Rocky, being the engineer who lived by the engines or the fuel tanks full of astrophage, was okay because of that.
Yes, the engineer, he had an engineering facility in the back of the ship with the engines and the fuel tanks, and those protected him from the radiation. He had no idea why the rest of his crew died from irradiation, who were in the front of the ship where there were no fuel tanks, and he survived living in the back of the ship with the fuel tanks.
So, question for you about modern science now.
Yes.
We, during the Apollo missions, obviously sent a lot of men to the moon.
Uh-huh.
And now, during the Artemis missions, it launched only a couple days ago. And if you don't know about that, go look it up.
Yes.
We have sent 4 more astronauts to the moon. How are we protecting them from radiation?
I've been wondering that, and I have not dug into the design of their capsule. But there's a couple of things to consider. One, the sun has this cycle. It's a 22-year cycle, and the Earth has a similar cycle, but it's tens or hundreds of thousands of years long. And what happens with the sun, it's a ball of gas, right? And like the Earth, it's rotating. But the Earth is rigid. And so the whole thing, the pole rotates at the same speed as the equator because it's a rigid thing. But the sun is not rigid. It's a ball of gas. But it also has a magnetic field. And the equator and the equator and the pole, they rotate at different speeds. And this has an effect of twisting up the sun's magnetic field, and it will actually get these loops in it. And if you look at the sun and the sun gets these sunspots, these sunspots are where a magnetic arc comes out of the sun and goes back in. So you look at the sun, you will see the sunspots mirror across the equator. So really cool, interesting thing, but not 100% related to Hail Mary, of course. But what that means is every 22 years, the pole of the sun will actually twist up so much that it flips. And the South Pole becomes the North Pole, and the North Pole becomes the South Pole. And then it flips back. So that whole flipping both ways takes 22 years. So every 11 years, the pole changes. And so there's this calm period in that 11-year cycle where the radiation belching out of the sun is significantly reduced. And they call that the solar cycle. So sending astronauts out, and I wish you were asking the question, because now I'm wondering, where are we in that solar cycle? Did they intentionally send the astronauts at a low in order to produce less exposure to the radiation? Don't know.
Yeah. I will say one thing I do know is that while the Artemis crew is up in space, they are conducting a lot of tests and experiments to try and figure out how we're going to do this longer term.
Mm-hmm.
And one of the things they are doing is they do have a radiation drill, or basically a solar flare or some kind of solar event were to happen. What would they do?
Solar flares, coronal mass ejections, lots of nasty things the sun can do to you.
Yeah. So what I understand,
much worse than sunburn. And we've all experienced that.
Yeah.
And it's much worse.
And sunburn's bad enough.
Yes.
But one of the things they're going to do is they're basically going to empty the cargo holds and use it as additional insulation and then climb into the center of the capsule, as I understand it. So
okay. Yeah, so some of the protections, of course, the aluminum skin of the Artemis would provide some protection. Of course, lead is a great protection, but it's very high density, which makes it very great for blocking radiation, but that also makes it very, very heavy.
Which isn't great for getting out of a gravity well.
Yes. So, take a moment, look at the whole Artemis sitting on the launch pad, and you look at all of that, and you look at how much that little thing at the top is all that's going to the moon. And so that entire rocket is how much energy it takes to get something into space. And it works out to be that usually about 5% of the mass of what you launch is all you're able to get into space. And so you start throwing lead shielding in there, and you're getting rid of things like, food, oxygen, people. And so you can get to a point where there's no longer any point of launching the rocket, because you've taken and provided so much protection. There's no weight left to put people in.
Which is why, correct me if I'm wrong, we stopped painting the center tank on the space shuttle.
Yes, yes, you know about that. I think it was the first 3 or 4 shuttle launches. Yeah, probably. But the first 3 or 4 shuttle launches, that center tank was painted white so it matched everything else. And they're like, this is 100,000 pounds of paint that we can replace with fuel and people. So it's just the bare insulation.
Yeah, which tells you, though, how much is factored into this weight. Like a tiny thin coat of paint, they're saying, no, get rid of it.
Yes.
We need to drop all the weight we can.
Yeah, when I was working on the Mars rovers, I was responsible for the avionics for the entry, descent, landing sequence. So, going from space through the atmosphere, deploying everything, then hitting the ground, coming to a stop, and that. So as it was getting close to the ground, it would turn on a radar and begin pinging to get the exact altitude it needed to cut the parachute, deploy the airbags, and hit the ground. We had 2 of those radars in case one of them broke. Well, we had a mass problem. And so we had this big review and had a big discussion. We said, we're going to accept the risk. And if it breaks, that's the end of the mission. We're going with just 1, because we needed a little extra weight for more solar cells. So yeah, mass is a huge issue.
Yeah, which honestly, I've loved the set they did for Project Hail Mary, the ship itself, because it gives you a feeling of what's up and what's down. you
Yeah, they did a great job with the
know?
zero gravity and creating centrifugal force gravity.
Yeah, and no fault of their own because I feel like it was necessary, especially for filming shots. But when I read the book, I imagined it so much more cramped than it was
Yes. When he
portrayed.
was when he was on the bridge, that kind of gave you a little bit of a sense of what it would probably really be like. But yeah, the rest of the ship was quite spacious, which
Yeah, the
wouldn't be the
VR room
case.
was fantastic.
Yeah, yeah, absolutely.
I
Yeah.
loved that room for the storytelling aspect, but there
Hmm.
was that corner of my brain going, why did you spend money on that?
Yeah. And you look at how big the capsule is. What did they name the capsule for Artemis?
Orion?
Yeah, maybe. No, Orion is the make, and they gave it a
Oh,
name.
yeah.
But anyway, you look at how big that is. There's nowhere else really to go, and there are four grown adults living in that space for 10 days.
And one of them's over 6 feet tall.
Yeah, just send the short people like me. Everyone will have more room to move around.
Yeah. No kidding.
But yeah, so they're living in that cramped space for 10 days. But of course, they have the whole volume because there's no gravity limiting them to the floor. So that does help.
Yeah, for sure. But it's again going back to that weight problem. What do we sacrifice and is absolutely necessary?
Yes.
And
Hmm.
human comforts, especially on a Hail Mary mission, weren't necessarily the top of the list,
Yeah,
unfortunately.
there was no VR room in the book.
No.
And yeah, and the food, not that great, but it was all usable.
Yeah.
It's what he needed to survive long enough to do the science, and then they hinted on it in the movie that each one of the astronauts had got to choose the way they would end their life at the end of their mission because there was no going home for
Yeah, and we'll make it as comfortable as we possibly can.
them. Hmm.
But space is a premium.
The Russian girl. Oh my gosh, she was funny.
I loved her. I'll have a whole movie about her, please.
Yes, exactly.
But actually, that brings me to something else: is his whole science station in the
Hmm.
ship, because clearly, for what he is doing, that part was non-negotiable, absolutely critical.
Yes.
And they made the decision in both the book and the movie that instead of trying to re-engineer every single device to work in zero G, let's create gravity.
Yes, that's right. Because all these instruments, everything we have on Earth, whether we think of it or not, we design it for gravity. And
Well,
so
I don't know how we
most of the,
wouldn't.
I know, right? It has to work in gravity. And so a lot of things you get into space and they just don't, without the gravity, they just don't work.
Yeah, thankfully the human body does. We weren't sure when we first started,
That's
but
right. Yes.
we
Yes.
can swallow in space.
We
Good
can
news.
swallow in space, right?
um,
But there are other problems. You begin to lose bone density, you begin to lose muscle density. Your heart actually changes shape and it shrinks to become a more efficient pump in a low gravity environment, which is extraordinary. The body actually adapts to low gravity, but it will eventually kill you. And that's not really something they addressed in the book or the movie. But astronauts have to be continuously working out to keep their bodies from utterly failing in the zero gravity environment.
yeah, so another necessity on a ship.
Yes,
Some kind of
exercise
workout
equipment.
equipment.
Yeah, it's a treadmill, but they just wear socks and have a smooth plate of metal, and they just let their feet slide on
I
it
love
because
that. I
why
mean,
not,
you're
right?
not going anywhere.
Not going anywhere.
But so the centrifuge they use to create gravity.
Yes.
I have heard several complaints from many a person now about that was the one thing of the science that they really failed to deliver on in the movie, was how the centrifuge spinning and creating that gravity would really have to work, because the
Hmm.
cable, the distance between the two spinning parts would have had to be much, much longer than it was displayed in the movie.
Yeah, I would agree with that. And plus, with that short arrangement, you can still get the gravity. You just have to spin a lot faster. But then what happens when you have a very short distance in a spinning object, you get a really, really bad Coriolis force, which you try to walk that way and you go off to the side because of this Coriolis force. And so it has to be long enough to reduce that Coriolis force, which is kind of, without explaining, it's kind of the curve you experience when you're moving.
So backing up a few steps, because
Hmm.
in case we lost someone, what is a centrifuge?
Oh, okay. So there are two ways to get what we refer to as gravity, and one is gravity, and it's directly related to mass. We have 32 feet a second of force of gravity on the surface of the Earth, or 9.8 meters per second squared, and that is all due to the mass of the Earth beneath us. And so, if you want this much gravity in your spacecraft, you have to take Earth with you, or that much mass. The other option is to use a centrifuge, which is a spinning object. And you see these at carnivals all the time, where they'll line everybody up against a wall on a giant wheel and spin it and then raise it up and tip the whole thing up so it's spinning like this. Nobody's really buckled in. They've got a safety strap on them, but they're being held in this wheel by the force of the spinning, which pushes you outward. And so that's a centrifuge. So if you want gravity in space so that your science instruments work, so that your bones don't disintegrate, so on and so forth, then you have to create the gravity, which you can do through spinning something. And it's, you get a plastic cup, not a glass one, get a cup, fill it half full of water, and then spin it like this, and you can spin the whole cup around without any of the water falling out. That's centrifugal force. That's what a centrifuge does. It creates a downward force in the direction of the spinning.
So I know this is an obvious question for you.
Uh-huh.
When he first woke up, he has gravity.
Yes. Yes.
But the ship
Of
isn't
course.
spinning.
Right.
So explain that one for our
Yeah,
audience.
in fact, this is, I of course don't want to embarrass the guy or call him out because he wrote a fantastic book, but he made some mistakes. He's acknowledged them.
Well, also, I feel like at some point you have to let go of the science to have a story.
Well, the mistake is actually in the brilliance. When he gives all the numbers for everything, and they were all calculated out. But when he calculated the amount of fuel that they would need in Project Hail Mary to get to where they were going and stop, he only calculated how much to get there. He forgot to add in the extra fuel for and stop. So he has a mistake in his numbers, but who cares? It's the concept is still there. But the idea of Hail Mary is that the ship underwent continuous thrust for half of the mission, got up to like 9.96 times the speed of light. So going at very relativistic speeds, time is dilating. And then he turned around and did the same thing in reverse to slow down. And so that acceleration that Andy Weir had calculated for this mission was 1.5 g-forces. And so there's some really amusing stuff at the beginning of the book when he is figuring out, where am I? And he creates a little pendulum because he knows something is wrong. And he, with the pendulum, calculates that it's 1.5 times gravity. And it's like, okay, I'm either on another planet or he's in a centrifuge, which he realizes. And he's like, why am I here? What is going on? This is so weird. But yeah, so it was the acceleration of the ship that provided gravity for the trip there. But once he got to Tau Ceti, he no longer could continue accelerating, or he'd go right past it, right? So that's when the ship split in half. And the book has the book ship design and the movie are very different. The book one is better, in my opinion. But once he got there, he could separate the ship on these cables and create centrifugal effect of the or centrifugal force by spinning the two halves of the ship on the end of a couple of long cables,
which provided enough gravity to make his science equipment work.
Yes, yes. And that's, in fact, if I remember right, that's why he first separated the ship. Was he was trying to conduct an experiment, and it wouldn't work because there was no gravity. And then he figured out, oh, hey, this is designed to do whatever.
Yeah, which is a point that is equal parts amusing and frustrating in the book, is when he's like, come on, brain, work. I have memory loss. I know I know how to do this.
I was so disappointed in the movie that, the computer would do nothing for him until he remembered his name. And that was so funny in the book, but they kind of didn't really do that in the movie.
Yeah, but
they had a nod to it, but yeah, I'll forgive him too.
The movie was so good. We're criticizing it because we love the science that the book's able to capture, but the movie just nailed the heart of it. And the feeling of the science, even if it didn't get in all the details.
Yes. Yeah. Yeah. And I thought the movie did an exceptional job. You know, with any movie, especially fantasy or the superhero movies, the audience has to accept a certain amount of disbelief. You know, I know that's not possible. I know that when Iron Man hits the ground at that incredible velocity, he is going to turn to jello inside of his suit because of those acceleration forces. Actually, what happens is, I learned this from my brother who's an EMT. The heart is in this bag of fluid that allows it to move around a little bit. And when you experience a very sudden deceleration, or acceleration, the heart will move further than the arteries will, and it basically unplugs your heart from the arteries, and you bleed to death in an instant.
Yeah,
And
let's
so
not put that in our fun fantasy.
right, yeah, exactly. So you have to have a certain amount of disbelief when you watch some of these movies. And one of the things I really love about what they did with Project Hail Mary, and all the science in the movie, is you could either just accept that it's happening, just like you accept Iron Man, or you can understand the science. You can pick whichever path you want to enjoy the movie. And I loved understanding the science that Andy Weir had used in creating his story.
And honestly, part of why we're doing this podcast, part of why we wanted to talk about this, is to help people who are at the first one, where they loved the movie and they just accepted the science, but want to understand the science. That's why we're talking today.
Yes.
Is because there is the science there. Most of us don't have 30 years plus all your years of education to understand it.
Well, so let me digress for a moment. There is a hope in me that Artemis will create inspiration in the youth to go into science and technology, because that's what happened to me in my childhood. I was living in Southern California, delivering the Orange County Register, which was a newspaper. You know what newspapers are, but Gen Alpha and you've got Gen Beta going here. They'll never know what newspapers are. But I used to, fill these bags with newspapers, hang them on the handlebars of my bicycle, and ride to houses and throw the newspapers onto their driveways. And then I had to go get the money from them at the end of the month, and we won't go there. But one day I get the bundle of papers from the truck that throws them out on my driveway. I cut the strap open up the papers, and there on the front cover is this almost spiritually moving image of the planet Saturn. And the image was taken in 1981 by the Voyager spacecraft, and before that we had never had a clear picture of Saturn. For you, the same experience was seeing the heart on Pluto, right?
Exactly.
That was that experience I had with Saturn, and that was so inspirational to me. It is a major one of several major reasons that I went into space engineering as a career. And I'm hoping that Artemis has that same effect on the geeks of the next generation as it did for the geeks of my generation.
And I have hope too, because the space world is getting more and more open. It's not just NASA anymore,
Yes.
which is subject to world politics and government spending and government budgets.
Mm-hmm.
And we aren't going to get into all of that. But now we have other programs that are saying, hey, I'm not connected to a government, but I am connected to the dreamers.
SpaceX, Blue Origin, two big ones. I mean, they're doing some amazing things, and they're doing it without government money. I mean, obviously, government's buying services from them, but with most of your big aerospace programs, the government goes to the big companies like Northrop or Boeing or Lockheed and says, look, we need you to build this, and we will pay all of your bills. And with SpaceX, that's not happening. The SpaceX is going to the government and says, I'll sell you a rocket for $2 million, and like, deal. And so the risk is all on SpaceX instead of being on the government. And so that switch is astronomical in the progress of industry in space.
And also, it's just us dreamers. We get to dream.
Yes.
We get to be excited about space.
The chopsticks catching the lower stage of the rocket.
Yes.
Like, is this CGI?
But We'll have to do another episode about the Artemis mission once it returns. We get everything because a lot of the footage isn't going.
Yes.
We can only broadcast so much back.
Okay.
As
And
I
I'll do
understand
some
it.
reading on how they protect themselves from radiation.
Great.
And we'll look at where we are in that
Yeah.
solar cycle.
But for now, we have science fiction stories, and
Yes.
we have our best friend Rocky in.
And science fiction, like Project Hail Mary, with those what ifs, it gets people thinking, and then they start solving problems.
Absolutely.
So science fiction is a critical part of human progress. Have we come to the end?
I think we are at the end.
Yeah, I've got a car to fix. It's broken.
Oh, well, that's less fun than a rocket.
Less politics than fixing my car.
Fair enough. All right, thank you.
See you in the next episode. There's
Good.
clearly some stuff we should cut out.
Yeah. Welcome to aerospace cookies. I almost said astrophage cookies. Oh, hi. Now stop kicking me.
That 40 weeks is truly the meaning of life, the universe, and everything. Not 42.
Aerospace Cookies, episode 1.
Wait, what?